ions? No, right?
No, sir.
We haven't done molarity of ions. Molarity on dilution we have done. Molarity of mixtures we have done. Right to topic. Molarity. Wait a minute. Right to topic. Molarity of mixtures.
Okay.
Have you done the homework?
Yes, sir. The homework was example 1.2, example 2.2, example 2.3, and in-text questions,
Yeah,
right?
yeah.
2.1,
Here it
2.2.
is. Example in text, and this is exercise. Have you done it?
Sir, I did tell in-text
Okay.
because I had some work from school and I was busy.
Okay. Okay.
Like I did till in-text. I did all the examples and did in-text questions till 5. So I mean I have to do 4 questions now.
Okay. Okay. No problem. So we are going to have a new topic, which is related to molarity, and basically it is molarity of ions. So this topic we are going to study with the help of a question. This is basically 4.9 gram H2SO4 in 250 centimeter cube of solution. Calculate molarity of A part, the H2SO4, which is very easy. B part, H plus, and C part, that is SO4 minus 2. You can do easily the A part. Can you do it?
So one of this, I'll write the question.
Okay, just write it and try it. Please let me know if you are unable to solve it.
So the first one can be solved, but the second one and the
Yes,
third one.
I want to answer for the first one. Second and third, I will explain.
Okay, then so one minute, I'll just solve it. I just wrote the formula, I'll solve it. So so
Yes.
is the molar mass of H2SO for 98?
Yes.
Yes.
Do you have any problem in finding molar mass?
No, sir, I'll just ask you. Let's check confirming.
Hmm.
So, So the answer is 0.39. So the first one.
0.39. Let me check. We have 4.9 gram H2SO4, and the volume is basically 250 centimeter cube. And if you are going to change it in liter, it will be divided by 1000, and it
1000.
will be 0.25
0.2.
liter, 25 liter. Now we need to calculate molarity. Molarity has a formula: number of moles of solute upon volume of solution in liter. For finding number of moles, it is not directly given in the question, but we have given mass. So we can apply given mass upon molar mass divided by volume in liter. What is given mass? Given mass is 4.9 upon
4.9.
molar mass is 98.
98.
Right? And
Yes.
the volume is 0.25 liter, and we can remove the decimal, and it will be divided by 100, right?
Okay. Yes.
Now we are going to calculate it. It will be 4.9 upon 98 into 20. This 100 will be in numerator. Okay, 100 divided by 25. Is that clear?
Yes, sir.
Now we can easily calculate this or solve this simplified. If you are removing this decimal, 10 will be in denominator, and now you can see 10 will be cancelled. Okay, Harsh.
Yes, sir.
And 49 will be cancelled by 98. 49 2s are 98, and this
90.
2 will be cancelled. 2 5s are 10, and 5 5s are 25. What
25.
we have left is 1.5 1 upon 5 m,
1 by 5.
or we can have 0.2 moles per liter,
Okay.
or
So
we
just
can also write 0.2
2 moles.
clear.
So I have some errors. I have 0.3.
Okay, so there is a mistake in calculation,
One,
right?
so one. I'll just check the error. I'll tell you.
Okay. Just check the error and let me know.
Yes, sir. Yes.
And if you are done with this, please let me know.
Yes, sir. Yes, sir.
Done.
Okay, so done, sir. Done. I just found the error.
Okay, now see. The first question is very easy, and
Yes.
if it is solved, the ions will also be solved like this. This is 0.2 m for H2SO4. Now for ions, we need to dissociate it to convert H2SO4 into ions. Yes
Yes,
or
sir.
no?
Yes,
It will
sir.
be H plus or SO4 minus 2.
Yes.
Is it balanced or not? Is it balanced? The equation I have written, the reaction I have written, is balanced or not?
It is balanced.
No, it is not balanced. How many hydrogens are on left hand
Two.
side?
Oh no, two hydrogens. Yes, so there will be 2.
Now it is balanced.
Yes. No.
Now see,
Yes. Now it is.
now it is balanced. Now see, you have studied in class 11th stoichiometry. Have you studied in the first chapter stoichiometry? That what is the stoichiometric coefficient of H2SO4 here? Can you recall it, or I should tell you?
So can you just tell me, sir? I'm kind of forgetting.
Okay, no problem. Do you know coefficient in mathematics? What is the coefficient of x?
Yeah, I have.
Or what is the coefficient?
Yes.
What is the coefficient of x here? Here.
3.
3. What is the coefficient here?
1.
1. Very good. What is the coefficient here?
Still 1.
1. The numerical value, the number which is multiplied in variable, is called coefficient. Is that clear?
Yes, sir.
But in chemistry, it is known as stoichiometric coefficient. Just suppose this H2SO4 is x. What is before this? 1.
1, yes.
So what is its stoichiometric coefficient?
1,
1. What is the stoichiometric coefficient of H plus?
2,
What is the stoichiometric coefficient of SO4 minus 2?
1.
1. So this is a stoichiometric coefficient, and you already know what is coefficient in maths. In chemistry, we call it a stoichiometric coefficient. Is that clear?
Yes, sir.
Now in class 11, you have studied that 1 mole of H2SO4, we take it as 1. 1 is there, 1 determine its stoichiometric coefficient. 1 mole of this will give, since it is reactant and this is product,
Product, yes.
2 mole of this and 1 mole of
1 mole of SO4.
Is that clear?
Yes, sir.
In terms of mole, we do like this. In terms of molarity, we also do like this. 1 molarity of this will give 2 molarity of this and 1 molarity of this. Is that clear?
Okay, yes, sir.
That means if this is 1 mole, this is 2 mole. That means H plus will have, if this is 1 molarity, this is 2 molarity. That means this is double of H2SO4. Is that clear? Double of
Yes.
H2SO4.
Yes, sir.
These two both have ratio 1:2, and this both have ratio 1:1. And we have molarity. We have molarity of 0.2 m. We just calculated it.
Yes, sir.
Yes. Wait a minute. Okay. You can see 1 molarity will give 2 molarity. Then 0.2 molarity will give double of this 0.4 molarity or not?
Yes, sir. Double.
Double. And you can see 1 molarity will give 1 molarity. That means 0.2 molarity will give 0.2 molarity.
Yes, sir.
So if you are going to find this, which is very easy to calculate the molarity of H2SO4, you can easily calculate the molarity of ions by dissociating it into ions and balancing it. So molarity of H plus is equal to 0.2 m, and molarity of SO4 minus 2 is equal to 0. Sorry, this is 0.4 m. I just wrote it wrong. This is 0.2. Is that clear?
Yes, sir.
Or I need to explain it one more time?
It's clear, sir.
Okay, where are you? Am I? Okay, very good. Can I change the slide?
Yes, sir. You can change the slide.
Okay, I'm going to give you another question which is on the same concept. 0.7.
Sir, can I note that down?
Yes, this is very important to note it down. Please let me know whenever you haven't read.
Answer.
Very good. I am going to give you another question on the same concept. 0.71% weight by volume, Na2SO4, calculate. The first A part is very easy. Molarity of first, which is Na2SO4, and B or C part is basically dissociation. After dissociation, we are talking about Na plus, and C is basically SO4 minus. Please do it.
Okay, sir.
Can you do this?
Yeah, yes, sir. Yes, sir. I'm solving the first part.
Okay, the first part is very important. Please do it.
Yes, sir. So,
Yes.
sir, here 0.7% of weight by volume of Na2SO4, right?
0.71% weight by volume. Yes.
Yes. So, uh, like
Whenever see
molarity
this
is enough solute, like mass by molar mass, right?
what you just said,
Sir, molarity is equal to N of solute by volume.
volume of solution in liter.
Yeah. So this is not, this is the mass.
No, see, whenever I told you that weight by weight percent, weight by volume percent mm, uh, will be
Yeah.
used in the application of molarity, molality, and mole fraction. See, whenever this type of term is
Okay.
given, you are going to change it in whole sentence that I taught you. Remember, if you are going to
Yes.
write it about this a sentence, what you will write 0.71 gram of
0.71 gram
Na2SO4
SO4
present in
okay,
tell me 100 ml because it is volume
100 ml
since
of Na2SO4.
volume is this is in aqueous solution. Always remember basically
Yeah.
Na2SO4 is in aqueous solution, 100 ml of solution. Now we are going to calculate molarity. Molarity is number of moles of solute upon volume of solution in liter. Okay,
Yeah.
Harsh? Now you will see that
Yeah.
this is the
Yes.
given mass and this is the volume. So given mass upon
Molar
molar mass
volume,
upon
yes.
volume of solution in liter.
Molar mass. Given mass is
Given mass is
0.7 gram
what is
divided
the
by
molar mass?
142.
1.
142,
Very
sir.
good. Upon volume is 100 ml, which we need to convert it into liter divided by 1000. Now see 0.71 upon 142 into 1000 upon 10. Sorry, 100. Is that clear?
Yes, sir.
Now if you are going to remove this, 100 will be in denominator.
Yes.
And now we are going to change this 0, 0. It will be cancelled by this 0, this 0. Now 71 2 ja 142, and we have a value 1 by 20 m or 20 moles per liter. Okay. Now,
Yes.
if you are going to divide it, it will be 0.005 m or moles per liter. Okay.
Okay, sir.
So this is the molarity of Na2SO4. Molarity of Na2SO4. Now we need to calculate the B, Na plus
Sir,
or
sir,
SO4 minus.
Sir, I'll solve that.
Okay, okay. Okay, okay. Please do it.
Yes, sir, I'll solve.
Please solve it.
Yes, sir. So for Na plus, is it 0.4 m?
0.4 m. Did you dissociate it into ions?
Yes, sir. Yes, sir. Na2SO4 into gives 2Na plus SO4, right? To that, right?
That's very good. 2Na plus SO4 minus 2. Just think about it.
Yes, sir.
One molarity of this will give two molarity
Yeah,
of
two
this,
of that, and then one of
and
this.
one more. Yes.
Yeah.
Now see, what is the reality?
1 m.
What we have is 0.05 m. We have this molarity, na?
Yes.
Double
Yes.
of this will be 0.01 m.
Yes.
No. 0.1 m. Double of this. If you are going to double it, because one it is from 1. So 0.05 will be, if you are going to multiply it by 2, it will be 0.1 m.
Yes, sir. 0.1
m. And it will be 0.05 m.
Okay, 1
okay.
Yes.
Are you getting my point?
Yes, sir. Yes, sir.
Okay, very good. Please do it.
Done, sir.
Very good. I'm going to give one more question on this, then we will move to new concentration term, that is molality. You have already studied in class 10. Okay, so basically, wait a minute. Wait. Okay. 5.85 gram of NaCl present in 500 ml of solution. Calculate molarity of A is NaCl, B is Na plus, C is Cl. This is the last question from molarity. Then we will come across molality.
Yes, sir.
Are you done with this?
So 1 minute, I'm just in the last part of A.
Okay. Just focus on your calculation. Accuracy is very important.
Okay, sir, 1 minute. Is the answer 0.2?
0.2. Let me check. See, molarity of NaCl, that is equal to number of moles of solute upon volume of solution in liter. Number of moles given mass, that is 5.85. What is the molar mass?
Sir,
58.5.
58. Yes.
See, Na has a molar mass 23. Yes or no?
Yes, sir.
And chlorine has a molar mass 35.5.
Yes.
So
Okay,
it will be 58. That's why I
35.5.
was calculating in between the question. I was calculating so that it will be easy to solve. Now, volume of solution 500 ml upon 1000, so that it will be converted into liter. Now, see, 5.85 upon 58.5
58.5.
into 1000 upon 100. Now, I'm going to solve it very easily. 20 will be cancelled by 20. Now, see, if we are going to remove this decimal, it will be
Into 1 by
100
100.
in denominator.
Yes.
If you are going to remove this decimal, it will be in numerator 10. Yes or no?
Yes, sir.
Now see, if you are going to solve it, 10 will be cancelled by 10, 10 will be cancelled by 10. This 585 will be cancelled by 585. Yes or no?
Yes, sir.
Then how much molarity we have? 1.
1. 1.
Yes or no?
Yes, sir.
Now see, NaCl has molarity 1 mole, and if you are going to dissolve, please do this on your own.
Na. So NaCl gives 2 Na plus 2Cl. So
Now, wait a minute. Have we done mistakes? Wait a minute. Maybe there is a slightly mistake. Oh, I realized this. This is basic. Wait a minute. Blender. This will be equal to 5.85 upon 58. What was your answer?
sir, my answer was 0.2, sir.
Okay, this is basically correct answer. Actually, I didn't consider 500. Here it was basically 100. I
So,
put
sir,
it.
my answer is
Okay.
correct.
Okay, yes, yes. I'm going to check it again. 20 will be cancelled by 20.
Yes, sir.
5 to 10. Now see, if you are going to remove this decimal, 585 upon 100, yes or no?
Yes, sir.
If you are going to remove this decimal, 585, and this will be 10 in numerator,
Yes.
and into 2, there is also. Now see, if I am going to solve this, this will be cancelled by this. 10 will be cancelled by this. and 2 by 10, which means 0.2. Yes, your answer was very correct. Okay.
So,
Now, can you solve the molarity of Na plus or Cl minus?
yes, sir, I'll just solve it. So it will still be the same because it's 1 mole.
Yes, NaCl, that will be equal to, if you are going to dissociate it, Na plus Cl minus. 1 mole, 1 mole, 1 mole. It is balanced 1:1. So if it has 0.2 m, this will also have 0.2 m, and this will
0.2,
also have
0.2.
0.2. Very good. Can we move to the next portion?
Yes, sir.
Okay. Now we have basically the next concentration term is molality. And never be confused about molality and molarity. Molality is denoted by a small m. See, molality, I am going to define it. Number of moles
Moles of solute
solute present in 1 kg of solvent. Present
Yes,
in
sir.
1 kg
of
of
solvent.
solvent, not solution. This is the concentration term in which in denominator we use solvent. In other, except this concentration term, in all the concentration term we use solution in denominator. Okay, or we
Yes,
can
sir.
also define it like number of moles of solute per unit mass of solvent kg. Okay.
Yes, sir.
So I'm going to write a formula for this mathematical formula. Molality is equal to number of moles of solute upon mass of solvent in a kg. This is the formula. In molarity formula, we had number of moles of solute upon volume of solution in liter, but in molality, we have number of moles of solute as it is in numerator, and but in denominator, we take mass of solvent in kg.
kg.
And what about units? Moles
Per
per kg.
kg. Sorry.
Kg, because it is mass in kg.
Okay.
Or directly we write a small m. That defines molality. Okay, please write it. Then I will give you a question on this simple formula. Very easy.
Done, sir.
Very good. Now I'm going to give you some questions. 10 gram of NaOH present in 54 gram of water. Calculate molality. Please do this. Can you solve it?
So
Yes,
0.72.
0.7. Just see. 10 gram of NaOH solute is given, the mass. Solvent has a
Sir, you're not audible. So you're not audible.
Am I audible, Harsh?
Yes, sir. Yes.
Yes, Harsh. The net was disconnected. Sorry. So here we are. Uh, 10 gram of NaOH present in 54 gram of H2O. Calculate molality. Molality is equal to number of moles of solute upon mass of solvent in kg. Am I audible clearly?
Yes, sir. Yes, sir. You're audible, sir.
Okay. Number of moles given mass upon molar mass. Molar mass is basically 40 upon mass of solvent, that is 54 gram, divided by in kg it will be 1000. So 10 by 40 into 1000 upon 54. Now just solve it and you will get your answer. Harsh, what was your answer?
Sir, I had calculation error, sir. 1 minute, I'll just do it. I can tell the answer 1 minute.
Okay, just do it, and I'm giving you another question, 10%. Wait, equals solve. Calculate molar?
Sir, I'm getting 18.
18 only.
Yeah. It's 18.5?
Yeah. 18.5. Yes.
Okay.
You can see number of moles that is equal to oh, 4. I just forgot
There
it.
is 39, sir.
Sorry. No, wait a minute. I just took 54. There is 4 also. So it will be
Yes.
4 into 54. And then you will get 54 into 4. That is equal to 206. So 1000 divided by 216.
206. 16. 0.0. 0.2, sir.
216. 1000 is in numerator, na? Denominator is lesser than
Yeah. Okay, yeah,
numerator.
4.6. Yes.
4.6.
Sir,
So
my
this
first
equation
answer was
from
close to this.
okay. We don't need to be close. We need to be accurate.
Okay, sir, done.
Done.
Yes, sir.
Can you solve the next question?
Yes, sir.
Please do it. Then we will start normality. And normality is very important.
Sir, is it 2.5?
What
Sir,
it
2.5,
is?
sir. 2.5.
What you just said, Harsh? 2.5.
Sir, the answer. 2.5, sir. Sir, you're lagging. I can't hear you properly, sir.
Harsh, am I audible?
Yes, sir. Now it's.
Okay, let me know if my voice is lagging or anything. Okay.
Yes, sir.
Now see,
Yes. So 10 gram of NaOH in 100 ml solution, right?
10 gram.
Sir, you're still lagging.
Yes. Okay, Harsh, am I audible now?
Yes, sir.
Okay, please let me know if
Okay.
my voice is
Okay, sir.
like always 90. So
Sir, when your video is closed, better voice is coming. I guess it's due to fluctuation on that.
one molar mass. So just better voice. Harsh,
Yes, sir.
yeah.
Sir, it should be
Can I switch off
100,
my
right? Yes, sir.
100 gram of solute or
Oh, okay, yeah, solution. So solvent should be 10 minus.
solvent molality.
Yeah. 10 minus 90. Yes,
I
correct.
told you that if 2090 and one cancel 25 is 100 and it will be by 9m. Are you getting my point?
Yes, sir.
Just write it and let me know if you are done with this. If you are done with this, let
Done,
me
sir. Done, sir.
know.
Done.
Okay. Okay. Stop. Normality. Is my voice clear now?
Yes, sir. Now it's clear.
Now see, normality is another type of concentration term. And before normality, we need to understand two terms. The first one is equivalent mass. See, this is very important to understand equivalent mass or weight. Both are same, equivalent weight or equivalent mass. It has a formula. Equivalent mass is equal to molar mass upon X. Okay. You can
Yes, sir.
calculate molar mass easily. Yes or no?
Yes, sir.
Can you calculate molar mass? Now,
Yes.
what is X?
Wait.
This X is basically no or we are going it is into for acid how we are going to calculate valence factor or n factor for base, and the third one is that clear? I'm going to tell you how
Sir, like, you're lagging in between.
you are okay.
Yes, sir.
Okay, wait a minute. Mm, You are not audible to me.
Sir, I can hear you.
Harsh, am I audible?
Yes, sir. Now you're audible, sir.
Okay. Actually, there is a storm in my area. That side,
Oh, okay.
the net is fluctuating.
Yeah, like it's fluctuating too much, sir. Like I
Just
can't
send
hear.
to me as word X. Can
Sir, I can't hear. It's fluctuating too much.
uh, uh, Harsh,
Yes, sir.
can yes, Harsh.
Yes, sir.
Wait a minute. Mm, Harsh, if my voice is too much fluctuating, uh,
Yes, sir.
then no problem. We can have class some other time because it won't be benefit for you.
No, but sir, now your voice is clear, but sometimes in the middle it's fluctuating too much when you're explaining things.
Okay, okay. Let
Like
me
now you're
know
talking to me,
when
it's
it's
normal.
fluctuating. Okay, okay. See, what is X for acid? Can you recognize whether it is acid, base, or salt?
X for acid.
No, no. What I'm telling you, can you recognize what is acid, base, or salt?
Yes, sir.
Yes. See, how to calculate the value of X if it is acid? The acid X is equal to the acid which gives the number of H plus. That means if HCl is there, how many H plus HCl will give? Only one H plus.
Yes, sir. One H
If
plus. That's
one H plus it will give, that means it has a value X is equal to 1.
okay.
That means the number of H plus is equal to X. Okay.
Yes, sir.
If you are going to calculate equivalent weight of HCl, that will be equal to molar mass of HCl upon X. And you know HCl has only one H plus. That's why it will be X has a value 1. Can you tell me how many H plus H2SO4 can give?
How many H2 is two, sir? No.
How many H?
So H plus and then SO4.
2. So what X? Yes, SO4 to minus 2 is not. How many H? If calculate
Two, sir. Two. Two.
equivalent weight molecule to this is what equivalent weight? Equivalent weight is equal to molecular mass upon X. And what is X? If it is acid, the number of H are you getting my point?
Sir, I
Harsh.
lost you. I lost you in the middle, sir. It was lagging. So in the last part.
Okay. Okay. Uh, Next, increase the
So can you hear me?
yes, yes. Can we have the class? I will increase.
So can I can't hear you. Can you write in the chat box?
Yes, yes.